think we got dy over dx equals negative x over y. Is that what we got? Okay. All right, so this was a circle, and we said it didn't matter what the radius was. That's what you were going to get every time for a circle centered at 0, 0. Let's look at what happens if we have a circle with a different center. The center of this circle, what would it be? 5, negative 2. All right, so we're looking to see if we get something different here. So if I take this derivative, I have to use the chain rule right here. So I would have 2 times x minus 5 to the first power. I would multiply by the derivative of the inside. That would just be 1 here. Then I would need to take the derivative of the second part. So I would have 2y plus 2 to the first power. And I would need to multiply by the derivative of the inside, which would be dy dx, because the derivative of that y is 1 dy dx. And then this would be 0. So I can distribute that 2 right there. I will get 2x minus 10. Over here, I've got the dy dx. I guess I want to distribute. So I'd get, I'm distributing the 2, and I'm distributing the dy dx. Are you guys all right with that? Like if I do that at the same time, it's a, so I've got 2y dy dx plus 4 dy dx equals 0. So I want to take these 2 pieces and move them over here to this side. I'm going to go ahead in this step and factor out that dy dx also. And then last step, I would divide by that 2y plus 4. So, well, actually not last step, almost last step. That gives me 10 minus 2x over 2y plus 4. So, I could take a 2 out of the top and bottom. So that'd be 2 times 5 minus x over 2 times y plus 2. And the 2's would cancel. And now I would have 5 minus x over y plus 2. So did I get the same thing? I did not. But is it similar?
Yeah.
Because I had dy, in fact it's really similar. I had negative x over y. If I factor a negative out of this, it's x minus 5, right? Because if I factor a negative out, I'll get a negative 5 and a positive x, so I could write that as x minus 5. And in the bottom, I've got y plus 2. If you look back at your original equation, you have, instead of an x, you got a x minus 5, and instead of a y, you have a y plus 2. And instead of negative x over y, you got negative x minus 5 over y plus 2. So while it doesn't give you the exact same derivative, it gives you a similar derivative right there. So like you could take that, like if I had x plus 3 squared plus y minus 1 squared equals 20. What would dy dx be? negative x plus 3 over y minus 1. Now, that's not something you got to have memorized or anything by any means. It's just kind of something cool.
Why is d over dx equal to x?
For a circle. For circles, yes. For circles. Now, any slight change in this, like if that's a minus right there, it makes it hyperbola. It doesn't happen anymore. If it's like if there's a 2 out here in front of this, that makes an ellipse. It's not happening there either. So any slight change from that would change what you're getting here. But if it's a circle, this is what you get. Now, again, no need to really have that memorized or anything. I just think it's kind of cool to see how it's different, but it's the same there. And if you think about it, like your curvature of a circle should be kind of constant, right? You should have like the same slope at different points there on the circle. All right. Yeah. 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 So, 6. This is a tangent line problem, but from an implicit differentiation equation, right? Anybody know what that one is? What's it look like if you graph it? It's an oval. It's an ellipse for that. Because you have an x squared and a y squared, but they don't have the same coefficient in front. So we did that some in pre-cal. This one is an ellipse. You don't necessarily have to know that. I was just testing you to see if you did. Actually, it's a wide ellipse. No. Yeah, it's a wide. Because you would have to, like if we wanted it in standard form, which we don't for this, but if we wanted it in standard form, we'd have to divide by 10 right here. So this one would have a bigger number underneath. Because over here, you'd have to like. But I don't think that counts.
That's not very This is blaze orange, eh? That's blaze orange. No.
He's getting old. He can't.
That's a bunch of piece of red right there. You ain't talking. I thought it's another name of land. Well, my family's name. I don't even cut short yet. You don't see a helicopter? Really?
Where was the helicopter at?
It come right up next to the building. Turned sideways like it's going to blow us up. Went down. Then it went out on the football field. Went down by the goalpost. Twisted around. It went over to elementary school. Started doing something on fire.
How did we not see this?
I don't know. It was right here.
Like during class right now.
Like about 30 minutes ago.
Is he messing with us?
Yes.
And I didn't have any problems.
Did anybody in here see?
It was definitely an RC.
What were they
I
doing?
didn't have no rocks, no water balloons, or nothing to defend myself with.
Slingshot.
I thought about doing like you did Top Gun and giving her number 1 seat.
Oh wait.
It'd be hilarious if there actually was a helicopter.
Throw something at the helicopter.
If there actually was a helicopter, that would be. I highly doubt there was. I feel like it definitely was.
I need someone else. I have seen a helicopter do what he described, I think, last year.
Really?
But
I don't remember.
but we noticed it because we I feel like he was definitely exaggerating that part. Yeah. I definitely think he was exaggerating through the goalpost.
Unless it was like an RC helicopter that went through the goalpost.
Yeah, I definitely think he was exaggerating that, but now last year there was a helicopter that did come pretty close to the building, was down there over the field, then went to the elementary school. All these things, same things happened, but
I'd like to see it.
I get distracted.
But
Dude, there's that one at the hospital. I called you a couple times.
Okay, let's finish this up so you guys have some time to work. So, we've got x squared plus 3y equals 10. We need the point or points and the slope. Okay? So, for the point, I would normally find f of 1. I don't have a f of 1 because I don't have a function here. X squared plus 3y squared is not a function. But the same thing is going to happen. You need to plug in 1 for x in the original. We can't call it the original function because this is not a function. And we can't call it f of 1 because this is not a function that we could define with f of 1. But the original equation that we're talking about, we're plugging 1 into that. So we're going to get 1 squared plus 3y squared equals 10. So 1 plus 3y squared equals 10. We could subtract that 1. We got 3y squared equals 9. We will divide by 3. We get y squared equals 3. Then what do we have to do? Not derivative. Square root. So y equals square root of 3. Is that right? Forgot something. I did it on purpose this time, actually. Plus or minus. Or they told us in AP Calculus training not to do this. The absolute value of y equals 3, and then that would mean a positive 3 or a negative 3. There's going to be a time where that actually might be helpful to us, but right now it doesn't matter.
Right, so do you leave up the square root? Do you absolute value?
Oh, I'm sorry. No. Still need the square root. If you think about plugging in right here, if you have positive square root of 3, Liam, then square root of 3 squared is 3, right? If you have negative square root of 3 and you square it, you will also get 3. Because when you square this, you're doing negative square root of 3 times negative square root of 3. And the negative times negative becomes positive.
So why isn't that plus?
Hmm?
Or why isn't that equal? Because like negative 4, the square root of negative 4 is 2. You can't have negative. I'm trying. Give me an example. I'm trying to help a student.
Yes. Leave Jeremy alone. All right. So what this means is you really have two y coordinates. You've got y equals square root of 3, and you have y equals negative square root of 3. So you have 2 points for this one place where x equals 1. So the first point is 1 square root of 3. The second point is 1 square root of 1 negative square root of 3. So we have 2 points, which does not always happen with these problems, but happens fairly often with these problems. So, all right, so we've got our points. Now we need to find our slope. So that means that we need to find for this dy dx, right? Which slope's going to be a little bit different too, because a lot of times we have an x and a y in our slope. So, what were we starting with? X squared plus 3y squared equals 10. This is a pretty straightforward derivative here. We're going to have 2x plus 6y dy dx equals 0. So 6y dy dx will equal negative 2x, and we will divide both by 6y. So dy over dx equals, we'll reduce that and get negative x over 3y. Now, for our other problems, we would plug 1 into our derivative. But if I plug 1 into this derivative, it still has a y in it, correct? So, whenever, this is one reason you need to find your points first on this. At this point, we're kind of splitting into two different answers because we're going to have two different tangent lines for this. So, let's see, with our points equal to 1 square root of 3, and then we'll have another one where our point is 1 negative square root of 3. So, notation-wise, this is going to be something we have not done yet. Typically, I do f prime of 1, right? But this is not a function. I can't call it f of x. So the way that we show a derivative, to show we have plugged something into an implicit derivative, is we're going to do dy dx. Then we were going to do this line right here that means such that. And at the bottom of the line, we're going to put xy equals 1 square root of 3. Okay, so that's some kind of weird notation that we haven't seen yet. But this is telling us that we're plugging 1 and square root of 3 into our derivative. So we will have negative square root of 3 over 3 times 1, which will give us negative square root of 3 over 3. So our equation right here would be y equals negative square root of 3 over 3 times x minus 1 plus the square root of 3. Definitely that can be simplified. Don't try. Unless you have to because it's multiple choice, leave it like that. Oh, I did it backwards, didn't I? I did it backwards. I got my x's and y's mixed up. Ugh, I need to go fix that. All right. Let's try again. You guys know I can't give those away for that. All right. So I should do negative 1 over 3 times the square root of 3. Does that look better? Negative 1 over 3 square root of 3. Now, 1 over 3 square root of 3 will simplify, but you don't have to, so don't do it. Just leave it. You can, like, rationalize that denominator if you want, but you don't have to, so just leave it like that. If we try the second one, we've got dy dx such that xy equals 1 negative square root of 3. So this time, let's see if I can do it right this time. Negative 1 over 3 times negative square root of 3. And since we've got a negative on top, negative on bottom, that's just going to be 1 over 3 square root of 3. So we'll get a positive for that one. So y will equal 1 over 3 square root of 3 times x minus 1 minus the square root of 3. So these two equations right here would be our equations of our tangent line. Right. Right, because you would multiply this together and get a negative 3 square root of 3, and since you got a negative 1 on top, negative 3 square root of 3 on bottom, they just can't, those negatives cancel each other out. Yeah. Now, let's look at this just so you guys, I think it helps to picture this. You can't use Desmos on this on real assignments, but I think to picture what's happening is helpful. So let's look at what it looks like on Desmos. So my original equation was x squared plus 3y squared equals 10. So there is my ellipse that I'm talking about, right? And I'm looking at where x equals 1. So I'm looking at these 2 points right here, right? And those points are the ones that we found. Oops, no, let's not do that. 1 square root of 3 and 1 negative square root of 3. Right? Those are the 2 points that we're looking at. Right? So we found those by plugging in. Then we had to find the slope, and we could write our equation of the tangent line. So that first equation of the tangent line should go through that blue point right there. So if I type it in, y equals negative 1 over 3 square root of 3 times x minus 1 plus square root of 3. You can see it goes right through that tangent line, right? If I type in the second, which is very similar, so I'm going to copy and paste and adjust it. That's got a positive slope. This number right here is negative, and you can see there's our other tangent line here. So a lot of times, a lot of these equations, since they're not functions, they have more than one point where your x equals 1. So you end up with more than one answer. Not always, but a lot of times. Okay? All right. This last, yeah. I thought we were going to do a trig one. I guess we're not. We'll do, I think one will come up later. All right, let's look at this last one. Okay, so for this one's a little bit more difficult. I got 3 times x squared plus y squared equals 100xy. I just want to graph it just to see what it looks like. I just like to see what these look like because they're so cool. And Desmos has made it where we can graph all this stuff, and it's so cool because you used to not be able to graph hardly anything. Everything had to be solved for y when it was just the calculator. Let's just see. 3 times x squared plus y squared equals 100xy. Oh, I like that graph. I really like that graph. Yeah, okay. So that's just because I like to look at these. You don't actually have to be able to do that. Well, let's look. Let's look. It's asking for the derivative at 0.31, so let's graph 3,1. Yeah, so we're looking, we definitely will have positive slope right there. So that's what we're looking for is does this one ask us for the equation of the tangent line? The slope. So that we can stop once we find the slope. We don't have to write the equation of that tangent line. Although, once you find the slope, the equation of the tangent line is super easy. But don't do anything they don't ask you for, because if you mess it up, you'll lose a point. All right, so if I take the derivative on the left side, what have I got to use?
Product.
Not product on the left side. Chain. 6x squared plus y squared to the first power times the derivative of the inside, which is 2x plus 2y dy dx. On the right-hand side, what do I have to use? I got to use product over here. So this one has you doing a lot. I'm going to keep the 100 out front as like a coefficient. You could put it with the x and do it that way also. So I'm just going to do x times the derivative of y plus y times the derivative of x, which is just 1. There. Okay. So over here on the right-hand side, I'm going to get 100x dy dx plus 100y. What do I do over here? Okay, how do I distribute? Okay, you could go ahead and put that 6, you could distribute the 6. Where does the 6 go to if you do that? Okay. 6x squared plus 6y squared. Do I distribute to the second parentheses? No. Because, like, if you, for example, if I had 5 times 2 times 3, right, I would do 5 times 2, which is 10, and then I would multiply that by 3 and get 30. I would not do 5 times 2 and 5 times 3 and get 10 times 15 and get 150. That would be wrong, right? So this, if you're multiplying, you can multiply the 6 by either one of these, but it's all multiplied together, so you're not distributing to that second parentheses, because if you were, it'd be like solving this problem the second way, which wouldn't work. Or you can keep the 6 out front and wait till you get everything together to distribute it. That also will work. All right, what have I got to do now? How do I put those together? I got to distribute like our FOIL, like we're got to, or sometimes use the box for that. So I'll do 12x cubed plus 12x squared y dy dx. It's getting some complicated stuff here. Plus 12xy squared plus 12y cubed dy dx equals 100x dy dx plus 100y. So we got a lot going on here. Everything with dy's needs to go over to the left side. So I got 12x squared y dy dx plus 12y cubed dy dx minus 100x dy dx, because I had to move that from the right hand side over here, so I had to change signs. Then on the right hand side I'll have that 100y. I need to move my 12x cubed, so that'll be negative. I need to move my 12xy squared, so minus 12xy squared. Whew. Take out that dy dx, we got 12x squared y plus 12y cubed minus 100x equals 100y minus 12x cubed minus 12xy squared. Your next to last thing that you need to do, what should we do here? Divide. So we divide by this stuff, 12x squared y plus 12y cubed minus 100x. 12x squared y plus 12y cubed minus 100x. I said next to last thing because, now technically you could be done at this point, but if this is multiple choice or if they've told you what the answer is supposed to be, they're probably going to reduce it. How could I reduce this? Because you got 100s and 12s everywhere. We can factor out a 4, or just divide everything by 4, whichever way you want to think about for that. So like if you think of it as factoring out, you're doing 4 is 25y minus 3x cubed minus 3xy squared over, factor 4 out of the bottom, 3x squared y plus 3y cubed minus 25x. And we would cancel out those 4's. And then I'm not going to rewrite that because it's taking too long anyway. There's my answer right there. Really, there's nothing terribly difficult about that problem, like every piece, but there's a lot of room to make an error, right? Because you've got so many different things you got to keep track of. 0.31. Oh gosh, we're not done. We're not done. We're not done. Because what did the question ask? This is easy to do too. What the question asked us to do? At the 0.31. Okay, let's pretend this is a free response question. Okay? If it is a free response question, we're plugging in 3, 1. We are going to write dy dx such that x, y equals 3, 1. I know nobody ever likes this notation and they want to not write it. But you need to write it to show, just like you need to put f prime of 3 if you're plugging in 3, you need to show, this is how you show what you're doing here. So you need to write it. If this is free response, you're going to do this. Be really careful on getting your x and y's correct. 25 times 1 minus 3 times 3 cubed minus 3 times, no, oops. 3 times 3 times 1 squared over 3 times 1, no, not 1. The x is 3 times 3 squared times 1 plus 3 times 1 cubed minus 25 times 3. Stop. Make sure that everything's done correctly. Make sure that you have parentheses everywhere there needs to be parentheses. Make sure all your signs are correct. If it's free response, don't figure that out. On a problem like this, they haven't asked you to do anything else with it, stop there, okay? It makes grading difficult on my part, but on a free response, you do not have to simplify that. And they're like, we have no time for you to do this, but if I had you guys all simplify that without a calculator, I feel like less than half of you would get the right answer. Yeah, I feel like, I think you all could do it, but I think the likelihood that you do it correctly the first try is not very high because there's a lot to do. Yeah, because you got to do, yeah, you start getting kind of big numbers, you got positives, you got negatives, you just got things that are wrong. All right, I think because we did not get through with notes yesterday and had to finish those up today, we are probably going to work on this, or we will work on this tomorrow during class, okay? So, it is, everybody listen, it is kind of long. It is a circuit worksheet that will, some of these are implicit derivatives, some of them are not, okay? So, what I would suggest, this is my suggestion. We're going to work on this some in class, but we do have the free response quiz at the beginning of class tomorrow. So you need, number one, make sure that's done because that will be great. And then you'll have, a little less than an hour to work on this. If you want to make sure you don't have homework over the weekend, then I would do a few of these tonight, maybe 5 or 6 of them tonight to get started on this. Because I do think it may take you longer than the class period tomorrow. If you're like, oh, I'm plans this weekend, I don't mind. You could just not do it tonight. That'll be fine too. But it won't be due till Monday. I am going to make some adjustments on Canvas because I did have a different assignment. I did have this due tomorrow, but I'll make some adjustments. It'll be due on Monday. The circuits, they're kind of hard, but I also think they're like great worksheets.
No, I meant just this problem.
Oh, the problem? Yeah, the problem was a doozy too.
Oh, this front and back.
Yeah. It's a lot of problems. That's why I'm suggesting you might want to do a few tonight if you want to try to avoid some weekend homework. But definitely don't do the whole thing because we are going to do it in class tomorrow.